Hi, welcome to my video. Now in this video, we are going to look at the electronic structure and the orbitals, okay? So now, this is what I want you to understand. This is the reason why we need to learn the orbitals of the atoms, okay? Now, there is a process that we call the hybridization, okay? Before the hybridization, we need to pass here, because when you talk about the hybridization of an atom, any atom that you can think of that you see on the periodic table, it will undergo hybridization. So any atom that will undergo hybridization is going to go hybridization by the combination or by the overlapping of their orbitals. So in this video or in this session, we are most definitely going to discuss the orbitals first so that we can understand when we talk about the hybridization, what is overlapping? How do these overlaps? I cannot be that person when we get to hybridization and I say that p orbitals intersect with this, it overlaps with these p orbitals, it overlaps with these p orbitals, but yet you do not understand what are the orbitals. So in order for us to understand that, this is where we are most definitely going to start, okay? Remember, this is the atomic structure. We are focusing on an atom before we can talk about the bonds, because before the bonds, the hybridization is supposed to take place, like I said, whereby the orbitals, they're going to have to overlap. So now this is what is happening, okay? I'm not going to dwell here at first. This is what I want us to talk about, okay? We're going to start with the basic, simple chemistry that we all know, okay? Right. So now what you see here on this slide, we have a simple diagram of an atomic model, okay? And then we have the electron configuration of an atom, okay? Now, what atom am I looking at over here? Now, this simple diagram of an atomic model, we know that the atom has the particles. Now, the centered particles are called the protons and the neutrons. And the particles that are found on the orbitals of an atom, we call them the electrons. Simple as that. But now the question is, what atom are we talking about here? Now remember, this is the first energy level, which can take a maximum of 2 electrons, 1, 2. And this is the second energy level, which it can take a maximum of 8 electrons. So how many number of electrons do we have in total? 1, 2, 3, 4, 5, 6. We have 6 electrons, okay? Now, I said the outer energy level for this atom, which is the second energy level, supposed to compose with 8 number of electrons. But now in this case, what is happening? We have only 1, 2, 3, 4, meaning it is not fully occupied, okay? So now this 6, which represents the number of electrons, it also corresponds with the atomic number on the periodic table. So you refer to your periodic table, you're going to check atom number 6. Atom number 6 on our periodic number, it is most definitely a carbon, right? It is most definitely a carbon. So this is a simple diagram of atomic model of a carbon, okay? Now I'll come back here. Now let's come here to an electron configuration diagram. Again, this and this diagram, they are exact same things, okay? It's just that the presentation, it is definitely not the same. But now let's talk about this, okay? So this is electron configuration, which is composed of energy levels and the number of electrons that are filled in their energy levels and their sub-energy levels. Now, the first energy level, it is called the s orbital, okay? The first energy level has only one sub-energy level, in this case, which is s orbital. Now, the s orbital, we know it can occupy or can take a maximum number of 2 electrons, which is definitely full. Therefore, we jump to the second energy level. The second energy level, there are 2 orbitals, which is s and p. The s will always be filled with a maximum number of 2 electrons, and the p will be filled with 6 maximum number of electrons, but the total second energy level supposed to be composed of 8 number of electrons. In most cases, we know that's how we obey an octet rule. Now, this is what is happening. Again, to be able to know the atom that we are talking about over here, we should count number of electrons. We have 1, 2, 3, 4, 5, 6. That means we have 6 number of electrons. We are also talking about the carbonic atom, the carbon atom. Okay? Right. And then we have the SP notation. The SP notation is the one that also represent, they normally call it, I've heard they normally call it electron configuration, which is 1s, 2p, all of those things. It is also the same. The presentations are most definitely the same. Now, let me go back to where we started, okay? Now, this simple diagram of atomic level, hence why I wrote simple diagram. It's simple because in actual world, it's even hard for scientists to tell the structure of an atom, but they studied the way they studied. Now, this is not exactly what we are talking about when we are talking about the atomic model, because we know that when you talk about the atomic model, we have to have that view of a 3D shape. Okay, remember, we are talking about an atom, guys. We are not talking about the interaction of 2 atoms or a molecule or compound. We are strictly talking about an atom over here. Now, this atom that you see over here, this is not the actual way on how to represent the atomic model. This is the simplest diagram to understand how to place the electrons and so forth. Okay? Now, you see, what you see over here, we're gonna redo this, but in a correct manner. Okay? All right. So remember, what did I say to you? I said we have the s orbital. Now, this is what I want to do before we can even discuss this in details. I want to show you the different shapes of the orbitals, okay? I want to show you the shapes of different orbitals. Now, these are the shapes of the orbitals. This is how the orbitals supposed to look like, okay? Now, this is 1s orbital. This is 2s orbital. Okay, you know what? Okay, the 1s and 2s, they are the same in shape. They are spherical. Both of them, these are the spheres. Think of a ball, not a circle, a ball, because this is a 3D shape, which has 3 different planes, which is X, Y, and Z, okay? And then this, it is also called the s orbital, but you can see the difference that the s orbital is a little bit larger than the 2s orbital is a little bit larger than the 1s orbital. Why? Because the s orbital, it is a composition, or it is composed of other orbitals inside of it. But I'll explain to you later on why is that the case. Is that the case? So these are the p orbitals. But you know what? This is what I want to do. I want to show you different shapes of different orbitals. Okay. Now in this slide, we have the s orbital. We have the p orbitals, we have the d orbitals, we have the f orbitals. S orbital, it has only one shape, which is spherical. Okay, which is spherical. And then the p orbitals are more or less like dumbbell shape. So these are the p orbitals, and there are 3 of them based on the 3D plane, which is X, Y, and Z. And then here we have the d orbitals, which are a little bit more complicated. But for this module, because you are not supposed to go further, we'll just discuss the p and the s orbitals. Okay. So these are the d orbitals, and then here are the f orbitals. You can see that as the orbitals increases, they get more and more complex. Okay, so we are only going to discuss this and these orbitals for now. Okay, right. So I want us to go back. Now you know the shapes of the orbitals, the s, the p in x, y, and z. Okay, now let's go back to our diagram. Okay, let's go back to our diagram. Now, I said to you, the s orbital in shape, it is spherical. The s orbital in shape, which is the second s, it's also going to be spherical, but I want you to denote the difference. The difference is this this sphere, it is now larger than the previous sphere. Why? I'll show you right now. Now, let us try to do an electron configuration for the very same atom that we have just mentioned over here, which is carbon. Now, if I have my Cartesian plane just like this in X, Y, and Z, okay? In X, Y, and Z. So here we have Y, here we have X, and then here we have Z, okay? So now this is what is happening. Let me change my color pen, okay? I'm gonna use, let me use this one. Now, this orbital over here, which is spherical in shape, it is the s orbital. So at the center or at the intersection of these planes, that means we have the nucleus like this, we have the nucleus like this, okay? So that means the first orbital, which is s orbital, I'm gonna draw it in a correct way, which is this. Now, this is the s orbital. The s orbital, it has a maximum of 2 electrons in it, right? Right. Now, we have from one s orbital, now we move to 2s orbital. Now, what is the shape of 2s orbital? It is s, and we said s in this diagram, it is spherical as well. It's more or less like a ball, okay? Right. So that means we're gonna have, let me change my color. Let me do this color over here. So now this will be my what? My 2s orbital, which is larger than this. Now you will see, now you'll understand why the 2s is larger than this. I mean, the 2s, it has to encompass the 1s orbital. So that means the 2s will surround 1s. Why? Because this 2s orbital is a little bit larger, it's a little bit higher than that one of 1s orbital. So that means what you see over here, we have the what orbital? We have the 2s orbital. Okay, now this is the 2s orbital, which inside of it, there is 1s orbital with 2 electrons. Even this orbital will most definitely take how many number of electrons? 2, meaning so far, what you see over here, we have total number of 4 electrons. Okay, all right. Now we move to p orbitals. The p orbital, we have the x, y, and z. So when you talk about the p orbital, let me change my color once more. Again, let me go black. Let me go black. So this is more or less like a dumbbell shape. Now, if I were to draw my Cartesian plane above here, x and y, remember this is x, okay? The x will look like this. Oh my God, I'm not good at this, but I'll try. So this is a dumbbell shape. So that means the s orbital will come in this way. Okay, I'm trying, guys. The s orbital will come in this way. The p orbital in x plane will come in this way. And these two orbitals, these two px orbitals, they can take a maximum of 2, 2, 2, 2, which is total of 6 for all p's. Okay? And therefore, we have the y orbital. Let me draw my Cartesian plane over here. And then this is y-axis, mean the y orbital will move like this. So that means over here, we're gonna have the y orbital. I don't know why I used the same color. Oh my God, my drawing is so bad. Okay, let me just erase only this one and most definitely use a different color so that everything can make sense and a little bit understandable. So let me use which color do you like? Let me go for this one. Okay, which is this. It's not the same. Yeah, it's not. So that means this, it's our orbital, okay, in y axis, okay, in y plane. So this is our another orbital. And therefore, that means this atom will most definitely look like this, okay? Whereby it's combination of all. That means this circle over here, this color, the 2s, it will disappear because we only have that. And therefore, the z orbital, it's an orbital that's going to look like this. Let me show you the z. Have our Cartesian plane over there, and then z supposed to come over here. And therefore, this will be most definitely at the back there. When they cross over here and will come here, let's just cross them, it's fine. And therefore this will be a z orbital. So atom will most definitely look like a shape that looks like this, whereby it's a combination of all of the orbitals. Okay, so this is how we see the orbitals, or this is how we discuss the orbitals. So I'm not going to complicate anything on this session. I'm just discussing only the orbitals, and therefore in the next session we're going to talk about the hybridization of the atoms. So this is just one atom. Now this atom, it is called carbon. So these orbitals, they're gonna overlap with one another, blah 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 blah, and that will yield to hybridization. But for now, I just want you to see how the orbitals actually look like and how are they situated on an atom. Therefore, we're gonna talk about the interaction maybe of two carbons. How do they interact? They're gonna form what bond, the pi bond, sigma bond, and all of those things. I hope this session was all making sense.